Here we're going to show how to plot a parametric curve. Not using a table though, we're going to directly plot the parametric curve from plots of x versus t and y versus t individually. And the particular example we're going to do today is x of t equals sine of t and y of t equals 2 sine of t over 3 between t values of 0 and 3 pi. So the first things first, if we're going to go from plots of x versus t and y versus t, is to actually go ahead and plot those functions. So first we'll make a plot of x of t versus t and y of t versus t as well. So again, these two plots are not our parametric curve. They are the individual coordinate functions that are functions of that parameter t. And if we plot sine of t, well, sine of t is or x of t is equal to sine of t between 0 and 3 pi, which looks like this. Okay, great. Now let's just plot the same, or not the same thing, but our coordinate function y of t. And the coordinate function y of t is equal to 2 times sine of t over 3, which looks basically like this. So again, the last t value we consider is 3 pi. The first t value we consider is 0 on both of these plots. So these are our coordinate functions as functions of that parameter t, and what we want to plot is actually the parametric curve that results, and we need to plot that on an xy plane. So a couple things to note. For our x function always goes between -1 and 1. And for our y function, well, that's going to go between 0 and a value of 2. So when we draw our coordinate plane, we can restrict how big the coordinate plane has to be. So we know that y is always going to be between 0 and 2. And our x values are always going to be between -1 and 1. And again, since this is a parametric curve, parametric curves live on the xy plane. So how can we go ahead and try to go from these coordinate plots into the plot on the xy plane? Well, we're going to do this very similarly as we did before for kind of going the opposite way from the parametric curve to individual coordinate plots. We're going to go basically point by point. So we can go ahead and start just dividing up our function into different points. And I'm just going to choose points in which, well, that correspond to the same t values. So for example, the value when t is equal to 0 for both x and y, then just another t value. And we can kind of keep choosing points similarly. So the big idea, I'm dividing my coordinate functions up just into individual points. Okay. Just trying to make sure that all of our t values are associated with the same in both the x and y. Okay. So these vertical lines I'm drawing are just to make sure that we can see what the x value is when t is a specific number and what the y value is when t is that same number as well. So when we're at t values of 0, both x and y are at 0. That's just the first point on our plot. X equals 0 and y equals 0 when t is equal to 0. And then as we march to the next point, we see what is happening is that x is going to a value of 1, and y is going to a value, actually it looks somewhat close to 1, but y is also increasing in some way. Again, this is just a rough sketch. We're not trying to be completely exact here. We're just trying to get a sense of what the sketch of the parametric curve looks like. So at the next t value, it looks like we're near 1, 1. Approximately again. This is just a sketch. If we wanted to be completely exact, we could make a table. All right, so from there, let's move on to the next point. Well, the next point, x is going back down to 0. And associated, y is still increasing, and it's increasing towards its max value, it looks like. So it looks like x is going down towards 0. Since it's going down, the x-coordinate is moving towards the left. And since y is still increasing, well, y is increasing, we are going vertically higher. So x is going to the left, and y is going straight, or upwards, I should say. So let's plot that point. Somewhere around there. Okay. Let's go to the next point. Well, what's happening to x? Well, it looks like x is going towards -1. And what's happening to y? Y is going towards its maximum value of 2. So it looks like we're moving there. X is equal to -1, y is equal to about 2. All right, let's step from there to the next point. X is increasing because x is going from -1 to a value of 0. So we're back on just the x equal, or the x equals 0 line, vertical line. And y? Y is slightly decreasing a bit. So x is equal to 0, and y is slightly decreasing. So where does that put us? Well, it looks like it's putting us back on the point in which we came from before. Okay. Well, let's see what's happening after that. X is going from 0 to an x value approximately equal to 1. And y is going from a number close-ish to 2 and going to a number just based on our crude plot somewhere nearish to 1. So it's looking like we're actually heading back towards that previous point. And then finally, what's happening from there? Well, our x value is going from 1 back to 0. So we're going to be again on the vertical line, x equals 0 somewhere. And what's happening to y? Well, y is going from that value back to 0 as well. So what is this curve doing for us? Well, if we go ahead and sketch this curve, this was the value when t equaled 0. We're at that point. Then when t was equal to the next value, higher, we marched along and got there. And then what happened from there? Well, we sort of made a left turn and headed that way. And then finally, when x was at its lowest value of -1, y was at its highest value of about 2, and we marched in that direction. So that took us to about this point here, or that red line. And then what happened after that red line? Well, actually, it looked like we turned direction and just went back on itself. And we headed the other way back down that curve. So this is perfectly acceptable for this parametric curve. Again, this is just a crude sketch of what is happening. But it looks like this curve, we are rounding going clock or counterclockwise up. And then after that t-value where x is equal to -1 and y is 2, it looks like we head back the other way now. So this is generally how we can try to sketch these parametric curves, coming from sketches of x versus t and y versus t. The big idea is we certainly go point to point and just ask ourselves what's happening to x and what's happening to y from point to point.